Thanks for coming this morning. This is the third last lecture. Today we're going to talk about going from script to a project. Next week I'm going to talk about scikit-learn, a machine learning library, which is going to be used in the last assignment. And then in the last week we will have another guest lecture. So remember that assignment 5 is due, the peer review of assignment 5 is due today, if you don't have an extension. If you have an extension, then it's on Saturday night. Make sure that you should also get a pull request for your own repository. So make sure that you accept it or reject it. If you want to reject it, then you should argue why you don't like the proposed improvements. Yes. So, okay, so today's lecture is going to be going from a script to a project. What I mean with that is that, so up to now, what we've coded up was mostly kind of on our laptops for ourselves, maybe for the peer review student that we worked with, but otherwise it was kind of self-contained. Today, I'm going to show you a lot of tools that you will use when you work in a production system. So with a production system, I mean being an open source or maybe professional software project that is where you collaborate with multiple people and that you want to deploy at the end. So make it available online as a website or maybe publish it as a library. And there's a lot of things that I've used in my daily, almost on a daily basis. And I think it's a lot of things that are extremely useful, but they're not really communicated in normal university courses. So I think it's really, at least I'm very passionate that I want you to know these kind of tools because I think they're really important. Okay. And I will do this entire lecture. It's going to be quite practical. So, and I will do the entire lecture based on this Monty Hall game that we developed last week. So the way we organize this is that, okay, so how do we actually go from a script to a project, right? So typical steps are that you start with the script and then you want it to be something more manageable, so you organize it into packages and modules. Then you start, then you add scripts and installation instructions. And then you add documentation and ideally make the documentation available online. Then you handle errors and add tests. And then finally, you want to deploy your application or your library. A lot of these steps you've done in a smaller scale already. But I will go through them again now and show you how you would do things more in a production-like system. Okay? And yeah, I added some links here if you have the slides in front of you or if you want to look at them later. So the results of that lecture today is a repository with all the files. There's an online documentation where I don't have the link now because we haven't generated it yet, but it will be online on the end of the lecture. There will be another website that hosts the automatic testing that we're going to implement. And then there's the actual online app that you should be able to click on this link and then it should run. So to make this a bit more concrete, we use the Monty Hall game from last week as a base example. Remember, this is what it looked like. And so far, the project simply consisted of a .py file, which we called gameserver.py, and some HTML files, which were the templates. Okay? And so the goal is now to make this into a more production-like system. So in particular, what is quite useful often is that you can run the game maybe also as a command line or as a web interface, depending on that you have both options. Then we want to add this online and offline documentation, tests, and error handling, and so on. So let's get started. So first, the first thing is that we wanted to restructure our program a little bit, so at least that we can have two interfaces, one command line interface and one web interface. And in general, when your project starts going, at the beginning you typically have the interface, for instance, the command line interface and the logic of the program combined in one file. And a good practice at that stage is then to break it up, to have one part of one library, for instance, that implements the logic of your library or program or what you're developing, and another one that handles all the, in this case, the input and outputs, right? Be it now the web application or the command line interface. So the way I thought about structuring this is that we make we create a new module that implements the core logic of the game. So without thinking about how to interface that, but I create a new module, a package here called Monty Hall Game. In that package, I create the init file to make it a package, and then here's my module file, which I also call Monty Hall Game. And in that stage, it's often a good idea to, before you start implementing the module, it's often a good idea to think about what is the most natural way to use that module, right? Think about the interface, the programming interface first before you start implementing the details. And so that's what I'm doing here. First show you how the module should be used, and then we can look at the implementation. So the way I thought might be a natural way of writing a module for the Monty Hall Game is, well, okay, so first you should import it. Then I thought it might be useful to create a new game, right? Because in principle, you could have many games in parallel. So you initiate this class to create a new game. And then how do you play a game? You first call the select door method, where you specify the door that you want to select. Then you call the game let host open method that returns the door that the host opens. And then you make your second choice, right? In this case, we stick to door number 1. And then at the end, you finally open the door. And then you either get true or false, depending if you win or not. Right? So this is kind of the logic that might work. And then finally, you might also want to, I also implement this game.statistics method that then prints out the statistics of all games. Okay, so now let's look at how I've implemented this. So you can now see here on the left, this is the directory structure. You can see that I have the templates. Nothing has really changed here. These are the template files. Here in Monty Hall Game, this is the package folder. And inside here I have the init file. In this case, the init file simply imports the Monty Hall Game module. And then inside the Monty Hall Game.py, I implement this game logic, the class. And yeah, so essentially it's exactly the same functions that I just described and the same logic that we went through last time, just implemented as in a class. And at the end, as always, I like having this if name equals main. So if you call that module as a Python file, then it will execute this and just check that the interface works. Okay, so now with this class in place, we can now implement also the two user interfaces. And this now, I've moved into a new directory called bin. So my project folder now contains a bin folder. These are all the binary files. And so you can see I have two files in here. It's play Monty Hall CLI. This is the CLI stands for command line interface. So essentially what I'm doing here is I'm importing the Monty Hall Game module. And then you can see I have a while loop. And inside the while loop, I print out yeah, essentially it's the command line interface. So I print out some information about the System Monty Hall game, then I ask for input, ask the user to input a door, and then I call the relevant module functions. So there's nothing special about this, but the main point is here now this command line, this interface file is now fairly short and doesn't contain any game logic anymore. It's all moved to the package. And then I have exactly the same thing for the web interface. So this is based on Flask again. And you can see we have exactly the same routes as before. So it's the /select route and the /reselect route. And really the only difference now, and really the only logic that happens now in the web interface is that I call the relevant module functions. So I create a new game here and access the game in the other methods as well. So again, now our web interface is just 60 lines long, mostly because we've outsourced all the logic into the main package. Okay, does it make sense? So with this in place now, I should be able to, we can just test it out if it works. So I have to, since we are this is not perfect yet, so I have to explicitly add this module, the current directory path into the Python path, like this. But then I should be able to type in play Monty Hall game CLI.py. Okay, so now I have my my command line interface. I can select the door. Then it asks me which word would you like to open. Okay, open door number 3. And then, okay, in this case I have 1. And show some statistics. Okay, and so in the same way, I can now also run the, okay, I need to install Flask. Okay, so the same way now should also work with the web interface. So let's try that. Yeah, it still works. Okay, so our new directory structure now has a bin folder where we have all the binary files that the user can call. And then we have the package that contains the game logic. And then we, of course, still have the templates. So now comes, as already mentioned, we still need to do this export Python path and so on. And that's because we haven't really installed, a proper installation would do a pip install and a setup.py file that we need to add still. So before I talk about the setup.py files, which you've already seen, I want to introduce you to another concept that is extremely useful. And these are so-called virtual Python environments. So the problem is the problem that this is solving is that if you're working on a single project, Python project, then essentially you have some dependencies that you install, right? And everything should work. But if you have 2 or 3 projects, these different projects might start depending on different library versions, right? So maybe you're working on one project that requires Flask 2.5, and then you work on another project that requires Flask 5.6, right? And then if you work on these different, if you switch between these different projects, you constantly have to uninstall Flask and reinstall the different version of the Flask when you switch to the other application, right? And now if you think about large applications, if you work on 5 different applications, right, this becomes really, really nasty. So these Python virtual environments are self-contained Python environments that you can activate and deactivate, and in which you can install your own library versions. And they will only be available within that environment. If you leave that environment again, you're back to your your system Python installation. So it's a quick way to switch between different Python environments. Okay, So I'm going to show you how this works, and I'm going to do it. I guess the easiest way is to do it live. So okay, so the way you do this, the way you create a new virtual environment is by typing in virtualenv. This is the command for handling these virtual environments. And then there's an optional command argument where you specify which Python you want to base it on. Right? So the virtual environment also, you can specify which Python you want to use. Right? Maybe for one project you use Python 2, and for another one use Python, in this case I want to use 3.7. And then the last argument is a directory folder, and it's in that folder where all the modules will be installed. So this is the name of the virtual environment that we're going to want to create. So I press return, and it takes a little bit of time, and it starts installing some basic modules, for instance, pip and setup tools, so kind of very essential packages that you want to have in any Python environment. If I now do an ls, you see there's a lot of folders here, but the most important one is that there's a new folder called env-name. And it's this env-name folder that now contains our virtual environment. But my system hasn't changed yet, so now what I can do is I can enter that. I need to activate the virtual environment. So you can see this. Maybe the best way to see this is if I type in which Python, it shows me, if I typed in Python, it would currently execute this home Simon Anaconda 3 bin Python. This is my system-wide Python installation. So now I'm going to activate the virtual environment. And the way you do that is you type in source, and then in the virtual environment name, so in inf name, there's a folder /bin activate. So that's what you need to do in order to activate that virtual environment. I press return. And you can already see I've set up my bash that it actually, at the beginning of the line, it shows me if I'm in a virtual environment. And it also shows me the name. So by just looking at the line, I can already see now I'm in a virtual environment. And I can type again which Python. And now you can see that when my Python command now, instead of executing the system-wide Python, I now execute a Python binary that is inside my virtual environment. Okay? So now if I type in Python, for instance, and if I want to import Flask, for instance, it's not available, even though in my system-wide I've installed it, but because I'm in my virtual environment, now it's not available. So the next step then is that I install all the packages that I need for my project. So in this case, I want to install Flask. So there we go. So I type in pip install Flask. It installs it all. But now it installs it in the virtual environment. Okay, so it's only available in the virtual environment. I can also, what else do I need? Sometimes it's useful to have this, it's called Unicorn. It's another web server that is useful. So, but the idea here is that then you start installing all the packages that you need, right? And then you can, maybe we install the Monty Python game as well. And now I can type in bin play Monty Python CLI, and now it works. And the web interface should also work. So now let's say you're done with this project and you want to go back to your base environment. You just type in deactivate. As soon as you type in deactivate, you leave the virtual environment, and if I ask which Python I'm going to execute, you can see I'm back to my Anaconda Python. And you can have as many virtual environments as you want. And also, if you want to get rid of them again, it's very easy. You just delete the directory name that you've chosen as the virtual environment. So you just do rm minus r env name, and now it's gone. Does it make sense? So this is really, this is really useful when you work on multiple objects. So now comes another a concept that I haven't really talked about yet, and these are dependencies. So any larger projects will have a bunch of,
Do you ever use conda environments?
Yeah. The question is, do I ever use conda environments? And I actually have it in this, I mentioned in the slides, I hope. So conda also has a concept of virtual environments, and they're extremely similar to the Python environments. So they also allow you to create self-contained environments where you can install conda packages. The only difference from a practical perspective, the only difference why you would choose a conda virtual environment over a virtual environment is that in conda, you can also install non-Python packages. So if your project depends on, for instance, a C library, right, on a specific version of a C library, then that you couldn't specify in a Python virtual environment, because Python virtual environments can only list Python dependencies, right? In conda, that's a more generic framework, so there you can also specify C libraries. So coming back to your question, I don't use them because not very often, because I typically use Python packages. And then if I'm outside, if I have a project where I don't use Python packages, I actually often use Docker, which is another concept that is even more general than conda. But I think conda environments are often very good, but it's just I personally don't use them so much. But so that just so you know, so virtual environment is Python environments are Python specific. Conda is also for other non-Python stuff, and then Docker is the most general, where you can actually choose an entire operating system. Okay, but I wanted to talk about requirements. So any larger projects will have a set of requirements that need to be installed in order for the project to work. Right? In our case, it's for instance Flask, and of course, kind of the most natural, the easiest way to describe these dependencies is that in your installation file you say, in order to run the software, please install Flask, blah 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 blah. Okay. But in Python, there's a more structured way of describing dependencies, and that's the way you do that is you create a file called requirements.txt inside your project folder, and that file is very simple. It's just a simple text file that lists the different dependencies that you have. So in this case, our project later on will depend on Flask, but also we will need PyTest and Sphinx. So for you as a tip, it's really useful as soon as you start a project, just create a requirements.txt file, and whenever you start using a new dependency like Flask, just add it in there so that you keep a list of the dependencies that you need. Okay, so, and then once you have this dependency list, you of course you need to install them at some point. And the way you install that is with pip install -r. And so -r takes in the requirements files. And then essentially what it does, it goes through that file and installs every single dependency that it finds in there. Okay? Make sense? Fairly straightforward. There's one thing that I can maybe mention. This is a bit, this is not always the best, well, anyway, I'll show it to you. I create another virtual environment. I activate again. Okay, So then I do a pip install Flask. Let's do just Flask. Okay, so now I'm in a new virtual environment. I just installed all the dependencies that I want. And so one easy way to list all the modules that I've installed is by typing in Pip Freeze. So if you type in Pip Freeze, it actually creates a requirements.txt file for you, as you can see. So here you can see Flask. This is the one that I just installed. And then all the other ones are dependencies that Flask has. And you can also see that it not only specified the dependencies themselves, but even the versions. So in principle, what you could do is you could now redirect the output here to requirements.txt, and then you have a ready requirements.txt that should work, that you should be able to use. Let's just look for this. There's a few problems with this approach, and that's why I like actually doing it manually better. The first one, as you can already see, it lists all kind of things that are only sub-dependencies. So really what you should do is you should start cleaning this up and get rid of all this stuff, because it's really Flask that you only depend on. And the second problem is that it actually also specifies the version. And that can be, if you don't specify the version and you do pip install -r requirements.txt, it will just install the latest version that it finds online. And of course, if you specify the version, it will install exactly that. The problem with being so specific with the versions is that this version might be some of the packages have versions that only work on Windows and only work on Linux, for instance, right? And so you might end up with these strange compatibility issues. So in many cases, it's actually best to just don't specify the versions and let pip figure out what is the most recent version that works on my machine. So I generally prefer this style over this style. But people disagree on that, and actually the tendency is that to have both, to have two files, one that only lists the dependencies, and another one that lists the dependencies plus the versions. Yeah, anyways. Okay, next part, setup tools. So we of course need a setup file to be able to install the package in itself. And you've already seen this a few times. I just want to go through it again because it will be important later on. So this is I created the setup file, and this is what it looks like. There's a few things that you maybe have not seen yet that I just want to go through. So first I import the setup function from the setup tools. This is normal. Then you need to provide a name. And so this name starts becoming important now, or at least later in the lecture, because we will publish our package online at the end of the lecture. And then it's this name here that determines what this under which name we publish under which name this package will be available online. So essentially, what I'm trying to get to is, at the very end of the lecture, you will be able to type in an entire new system, and you type in pip install Monty Hall game, right? And then it will install the Monty Hall game. It will find it online and install it. And the reason why it works is because I gave it this name here, Monty Hall game. This is how it's connected. Then there's also a version. This also becomes important as soon as you publish online, because online you will have a version history of the different versions of the Monty Hall game, right? And if you want to publish a new version, you will have to increment that counter here. Then there's an author, right? All this stuff will be then used when I published it online, even a license. And then, so packages that you've seen, right? So packages is a list of folders that contains the packages that you want to have installed. There's a new thing that you might not have seen yet, and that's scripts. So scripts is again a list, and in scripts you specify Python files, or can also be bash files, but anyways, executable files that you want to be able to install not as packages, but actually as executables. Right? The difference here is that if it's a package, later on you will be able to type in import Monty Hall game. If it's a script, at the end you will be able, just in your terminal, you'll be able to type in play Monty Hall game, play Monty Hall CLI.py, and it will just run it. But maybe I can just show it to you how this works. So yeah, this is how you install it, either with Python setup.py install or with pip install dot. And then you can also install it again with pip uninstall Monty Hall game. But I just want to show you what that this becomes clear. So I'm still in my virtual environment. I've installed the dependencies. Or maybe let's just do that. I do pip install -r requirements.txt. Okay, so now, okay, it needs to download PyTest, I guess, and Sphinx. Okay, so it's done that. So now I do pip install dot to install the Monty Hall game itself. And so now I exit the directory. I'm now in my home directory, nothing related anymore with the source, with the package directory. And so now I should have this play Monty Hall game CLI.py, for instance. I have it available as a command. And the reason why it's now available is because I added it in the scripts as a specific script that I wanted to install. Okay? And of course, also, if I open up a Python, I should be able to import this, I hope. Yeah, so also that package is available. Does that make sense? Yeah. And then, of course, we can uninstall it. Let's try that also. Pip uninstall Monty Hall game. Okay, it asks me if it's okay, and then it's gone. Okay, so finally, I mean, this is trivial, but it's very important that any good project has a README file. Typically, I use this MD format. It's Markdown. It's just this very simple text formatting. So you use, for instance, these equal signs to specify headings and single colons to specify subheadings. And the reason why using this Markdown is a good idea is because when you go to GitHub, so this is the GitHub repository of that project. And if you scroll down a little bit, you can see that it automatically, GitHub visualizes this README file, and it visualizes it. So it renders the Markdown as nicely, right? So you can see now I have my headers and so on. So this is really the main reason. And you can have the source code here nicely and so on. And so in general, it's good practice that any project should at least describe how to, it should say what it is, right? It should say how you install it, and it should say how you use it. Most important things. That if you don't have these three things, then add them. Okay, so that was the README. So, okay, so now our project is a little bit larger already. So we have 3 new files, readme.md. This is our installation instructions. Then we have the requirements.txt and the setup.py file. So typically one does not, or typically you do not include the virtual environment as part of your GitHub repository. This is something you do locally, but you don't really do it on the GitHub repo.
These scripts that you were able to run, did you have to load the library before you can execute them, or can you just execute them anytime after you install them?
Okay, so the question is, these play scripts that I also installed, the question was, do I need to import the package first before I can run them or not, right? And so I do not have to import anything. So the way this works is that, let's have a quick look at this, at these scripts again. So if I go to bin, and let's look at the command line interface. Okay, so the command line interface is that's just a simple Python script, and what it does, it loads. So this Python script loads the module Monty Hall game. Okay, and so the reason why this works, why I can import this, is because I also install the package. Right. So by installing the package, this import statement will work on any Python environment, and it will specifically work in the case where I run this command line interface. So the answer the concrete answer to your question is you can just type in, open a new terminal, type in play Monty Hall game CLI.py, and it will just work. There's no need to import stuff.
But can you do it from, like, you have to be in the package folder?
No, you don't. I mean, so in my case, the only requirement was that I need to be in my virtual environment, because that's where I installed it. But I just demoed to you. So now I'm not in I will install it system-wide. I go to Monty Hall game. I do pip install. Maybe just let's install the requirements.txt. And pip install dot. Now I install the Monty Hall game. Okay, so now I open a new terminal. Okay, I'm not inside the project folder. And this becomes available. And that's the point, right? I mean, you want these commands to be, you want to install it and have it available wherever you are, not just in your project folder. Any other questions? No? Okay, so the next thing is that we should always have documentation, and you're already extremely well skilled in writing documentations and doc strings. So I don't explain this again. I will just mention that we will now, in a second, we will generate online documentation. And in order for this to work, in order for this to work well, the documentation needs to be written in a specific standard. Because we're using Sphinx to generate these online documentations, the documentation needs to be written in this Sphinx markup style. So it's not, again, this is not very complicated, but it's just something that you need to be aware of. So I guess, yeah, on this, we don't need to go through this. You can find all the details in this link, but I just want to show you what this documentation looks like in practice. Let me go here, Monday Game 2. So I guess the best one is maybe this montyhallgame.py. And this is now the documented version of my class. And here I followed the Sphinx guideline. So you can see code is used to mark code. I use these double single colons. Where else? Here, for instance, you specify what it returns using this colon, returns colon, for instance. Yeah, I think that's about it. Yeah, so here, for instance, when you have a function that takes in a variable, door, you can specify, you can reference to that variable in the documentation. So you say ivar, so the documentation for the variable door is the following. And the reason why we do that is because it's going to be rendered nicely in a second, right? So by following the standard, we get a nice documentation at the end. Okay, but of course, so now once you've documented it all, once you added these doc strings, we can use this question mark magic here, for instance, to get the documentation of a specific function. And so let host open door. When this function is called, the host will open a door that contains no price. Okay, and it returns here, or you can see it returns the newly opened door as an integer. Okay, so that's the developer version of the API. But when you've imported the modules and you want to know what a specific function does. But often it's also useful to have the documentation available online as a website. And the simplest way of doing that is to use pydoc. So what that does is it's a program that takes in a Python file or a Python module, and it generates either text or HTML documentation. So usage is very simple. You type in pydoc Python file, and then you get the text version of the documentation. Or you use pydoc -w Python, and then the Python file, and then you get the HTML version of that documentation. Let's test it out. You can even run it as a web server. Okay. So let's test it out. So here I run pydoc -w for the web version, and then I want to have the Monty Hall game package or module documented. So I run this. You can see it wrote out an HTML file, and then I can just open it up in a web browser. And it's not the prettiest documentation, but you can see all the core information is there. So we have one class. So we have, let's see. So this is the Monty Hall game module package. It imports two modules, random and UID, and it defines one class, namely Monty Hall game. And then down here you find all the methods that it implements, including the doc strings. Okay, so but of course a proper documentation is much more than just this page, and so I want to show you. So so this is kind of a very what I've shown you just now is just the documentation of a single module. But really what we want is we want to have a documentation of entire project, right? And for that we will use Sphinx. So I just want to show you one of my projects where I used Sphinx, that you have an idea what the result can look like. The project is called Open Title Farm. It's an open source simulator that I developed to simulate tidal turbines. And this is the web page. And this is essentially built with this Sphinx tool. So you can see it has some nice sliders. It has some features, news, yeah. Okay, but then what else do we have? We have installation, instructions. Okay, just some examples. You can click through the examples. You can see there's some mathematics in here, some pictures, and then the implementation with the code. But then also we have the programmer's reference. So this is essentially now the API. And then, for instance, I can go, we have domains and problems. So let's look at the steady shallow water. Okay, so now you can see here, this is now the class definition. And the doc string down here, the text below is actually the documentation string, and you can see the doc string can also contain some mathematics here. Here are the parameters that it takes in. And you can even click on source, and then you get the source code of that specific class. Okay? Do you get an idea what you can do from kind of not just documentation of a single module, but really essentially entire web page of your project? Okay, but I think we create a Sphinx documentation of our Monty Hall game after the break.